Let me start with the session. Anybody from operations, please confirm if my screen is visible.
Yes, it's visible.
Yes, sir.
Thank you. Yeah, thank you. So today's topic, wingsuit aerodynamics. Now in this overview, we'll study free fall concept, aerodynamics of free falling, then wingsuit design and its dynamics, wingsuit applications. And in applications, we'll talk more about the Spiderman and where it prevails, where it fails, and what sort of real life practical applications of wingsuit could be made possible. Okay. Now coming to the free fall concept, can anybody tell me? It's a basic motion concept. Okay, when we talk about a free fall, if I give you a hypothetical scenario where I have a feather in my right hand and a steel lamp in my left hand, if I drop them from same height and just leave them to fall, which one will reach the ground faster?
Both reaches us at the same time, sir.
Same time.
Yeah.
When it is in vacuum.
Oh no, when it is in normal atmosphere, not in vacuum.
Both reaches the same, sir. Even Galileo.
Okay, so whoever answered first, can you please explain, elaborate why?
Because gravity acts equal upon any object, sir. Even Galileo tried this experiment in church.
Great. So basically the concept is your acceleration due to gravity is independent of mass, due to which basically this is the deduction that Galileo deduced after creating or after experimenting with this idea. So basically, if I show you, so if I have a larger ball over here and a smaller ball over here, if they are falling independently, this larger ball will have its own density, it will have its own mass, but the speed at which they are going, they're accelerating, is the same. So if this one has larger mass, this one has larger mass and adequate density, this one will also have its own density and its own mass. But the thing is, when you're accelerating in the downforce, due to the only force that is acting is your gravitational force. That is, these guys are moving with are accelerating through the procedure using acceleration due to gravity. And due to that action, this concept is called free fall, basically. Now, when we talk about free fall, the first thing that comes into mind is when we do skydiving, right? So it is the closest thing. Just a minute, yeah. It is the closest thing that comes to wingsuit. If we talk about wingsuits, that's the closest thing it comes to. Now, what is the biggest difference between this wingsuit dynamics and the free fall? Can you tell me? If I jump off without a wingsuit, if I jump off directly from the skydiving, and what is the difference when I jump off with the wings? Can anybody tell me?
Wingsuit will create air resistance and it will reduce the speed, sir. Whereas without wingsuit, the resistance offered by the air is negligence, and we will fall with a third sound, sir.
Okay. So it was absolutely correct. From technical side of things, it was absolutely correct. From conceptual side of things, to tell you, if the basic idea is when we are jumping from this without a wingsuit, there is less dynamics, less movement you can do. Of course, you can direct yourself, you can speed up, you can slow down, but there is a limit to that. With wingsuit, you can do it with much more guided way and with much more control. So that's the biggest difference you have with this free fall concept and the actual wingsuit. Now, when we talk about free fall aerodynamics, so I'll just take you through this just a minute. Basically, if I'm trying to fall from top, from, let's suppose this, just a minute. Suppose this is a place where I'm trying to fall, where I'm considering to fall from. My drawing skills are not that good, so I really apologize for that. But just to consider, this is a helicopter, okay? This ball of whatever is a helicopter, and I'm trying to jump from that. Then this small head is kind of, just a minute. So this object is me. I'm trying to free fall. So what happens is when I'm trying to free fall, there are going to be this downward force that is going to be acted upon me. And if I want to change my trajectory, now in this case, if I don't move, in this case, I'll just again drop down in the straight direction, and the third sound will come on. The other person just said, so that will happen. But when I switch my position, so basically, if I take it as a side view, let's consider this stick and this is me, and if I'm trying to tilt down, so let's suppose I have tilted down in this way. So what happens in that case is I will have basically air resistance in a guided way. Basically, the idea is if I tilt down in forward motion, this will form a triangle. This triangle, oh, just a minute. This triangle it will form. So I'll just, if I draw it in a much nicer way, this triangle will form. This triangle, what it determines is, and this position is this position. Okay. What it determines is the amount of fall that I'm having. Let's suppose if this is 1 meter in vertical direction, if I have the speed I'm going, consider for every 1 meter of distance, I will have a significant more amount of forward distance. Basically, I'm trying to reduce my vertical distance or drop and increasing in terms of horizontal distance. So this concept itself is applied in while you're flying with a wingsuit. Essentially, the application of wingsuit is when you're trying to move at a pace where you are trying to move through air, basically, where you want to cover more distance, you want to get from A point to B point. You basically want to sustain a lot longer in the air when you are trying this. Okay, so that is the basic dynamic. So basically, you want to fly like a bird. You want to fly like you want to sustain your flight as long as possible. This concept helps you do that. So this is a very fundamental way of explaining aerodynamics. Now, let's come to the wingsuit general shape. Okay, so this is your wingsuit general shape. So this is when you practically see. So as opposed to the movies, basically it has some cool effects that they have done. They usually make to make it look more aesthetic, to make it look more dynamic, future-proof, you may call it. But we are still not at that stage. We are still getting there. So the actual real representation looks something like this. Can anybody, so there are, okay, never mind. So there are a few concepts that we need to understand first in order to get into the deep understanding of this wingsuit. Before that, if anybody has any questions regarding the free fall dynamics or how the diagram works, you can ask.
So how can we increase the ratio, sir? Like 1:3 or 1:9? We are listening.
Yeah. So the basic idea is it depends on your angle of attack. So I'll just show you over here on the side. If my angle of attack is something like, if this is my horizontal line, if my angle of attack is this, in that case, I am covering this much horizontal distance. Okay, this much vertical distance, but this much horizontal distance. Okay, so it actually depends on the angle at which you are going to pitch, basically. So if it's more, then again, the drop again increases. Also, it increases the distance accordingly. So this dynamic is based on the, you can just use the general Pythagoras theorem to actually figure out this ratio. So that's how simple it is. In terms of understanding it, in terms of as a sole concept. When we get into the wingsuit details, I'll get back to this concept and how it is implemented in wingsuits. Because when you are free falling and when you are falling with an wingsuit, it both gives there are different factors affecting this ratio, what I have just said. And also it has, this ratio actually depends on a concept called aspect ratio, which is calculated from the wingspan square divided by the area of the wing. So that will also see, okay. I just want to request everyone, if please refrain to ask any advanced questions for this moment. Just ask whatever those who have questions about the free fall dynamics at this stage. Yeah, Pranjal Rajput commented flying squirrel anatomy. Yes, 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 yes. So yeah, we will. I'll also explore that one. Yeah. So sure. So if there are no questions, I'll switch back. Yes. Does anybody want to ask a question? Okay, never mind. So this is your wingsuit general shape. Now, the basic idea is basically, let me just show you. The horizontal line that you're seeing, that is the distance between from this hand to this hand, the amount of stretch you can make with this is called as wingspan. This is called wingspan basically. Now, when you are wingspan, and this, the overall area that you're seeing over here, over here, over here, this is your wing area basically. Okay. So these are the two most important terms that we need to understand while we are going into the design aspects of it. So this is where the real magic starts. Now, when you have the general idea about how wingsuit looks like now, you have a conceptualization. Now let's see the application of it. So when you see it from the front, okay, it looks something like this. Just remember this picture in your head for now. So from front, it looks like this, and from sides, it looks like this. Okay. Now we will study the aerodynamics of the wing. Basically, in aerodynamics, in any aerodynamics, if you want to be as more efficient as you can, because when you are flying or when you are moving through air, or falling in this direction, may be anything, you will feel resistance. You'll feel resistance due to the air. Okay, and due to that resistance, it is called as drag. So that resistance will kind of restrict your flight in terms of like creating some maneuvers, moving in different angles, moving in different ways. It kind of restricts that flow. So in some way or the other way. So what we do is we have an ideal shape design, which is called as aerofoil. So this is the shape in which if any object is falling, if it has this kind of shape, in some way, some shape or some form, then it is the most optimum shape where you can reduce the drag, and its other advantages are also there. So we will explore those advantages at a later stage. For now, just stay with me. Consider this as your baseline. Now, the problem with the initial wingsuits was because this is what we are seeing over here is the latest version. It's a kind of advanced version of the wingsuits. Previously, they used to like a kind of a this is a very very rough sketch, but these were used to the shapes when it was started in late 1930s or 40s. When it was started to conceptualize, this was the shape. Later on, this shape got improved. The main reason was this aerodynamic drag. Due to this drag, you are unable, if it used to restrict your movement. Okay, so what happens is if you focus on the current advancements that are happening, so as you can see this shape, even if you see this idea, the biggest challenge or the biggest challenge was to introduce that drag. So, okay, let me take a few steps back here. When I'm talking about an aerofoil, if this is my aerofoil, I'll just erase everything. Okay. Then I'll start. Yeah. If this is my aerofoil, I'll feel if I'm moving in this direction, if my wind is acting in this direction, then it will feel drag in this direction, like it will feel drag in horizontal direction. And there will be like the wind will split. The wind will go, some wind will go from upside, some will go from down. And the upside wind will kind of, it has to move in a very specific way, in a very streamlined way, in a very smoother way, in order to provide less friction, in order to provide less resistance, basically, not friction, but less resistance. Now, whatever the wing that is flowing from downwards, this wing helps us provide a kind of a push, which is called as lift. So there are two concepts here. One is your lift force, one is your drag force. Drag force will resist your motion and lift force will lift you up. Now, this way you will be able to stay in the air. Also, once you understand these two concepts, basically, you need to understand this. If, for example, my air, I'll just once again while erase. I'll erase it. Okay. Now, if I just go ahead with this, something like this, if my wind coming is from this direction, what this will do is it will push me down, right? It will push me down. It's just, it will generate enough amount of drag that it pushes us. Basically, it doesn't work. So there is only an optimal condition in which the wind should be directed in such a way to this tip of the nozzle of the aerofoil. And we need to follow this in order to reduce the drag, okay? In order to reduce the drag. So that's why the aerodynamic shape is really important, and that's why the flight dynamics is very important. Now, everybody is with me till this stage?
Hello.
Yes?
Hello, sir. This lift is how generated, sir? According to Bernoulli's law or according to Newton's third law of motion?
Bernoulli's law is kind of a derivative of Newton's third law, if you ask me, and Bernoulli's law is going to be used for this.
Okay, sir. But sir, some people say that there is a Newton's third law of motion. There is no Bernoulli's law.
Okay, so I haven't gone through in that detail, but yeah, if we use Bernoulli's equation, Bernoulli's principle, I believe that Bernoulli's principle is kind of a very complex derivative of Newton's third law. So due to which, because it's not just the air force we are talking about, there is gravity involved, there is all sorts of forces involved which all work together to form a resultant. And essentially, if your resultant is giving you an action, you are countering that action with equal and opposite momentum, equal and opposite reaction, may it be in the form of momentum, may it be in the form of force, may it be in the form of impact. So it can be anything. So it's not directly to be said in that way, but yeah. So it is a complicated derived form of Newton's third law, if you ask me.
Okay, sir.
So the idea of generation of lift, right? Essentially, when you're, so this is a very detailed topic. I will not be going into that much detail of this, or otherwise this will only take the rest of the time that we have. So let's just stick with this idea. We have two concepts. One is drag, one is lift. Drag is basically your resistance to the movement. If you are moving in certain direction, if you are moving in opposite direction, you will face drag in opposite direction due to the movement of the air. And if you are in air, basically, then in that case, you will also feel some amount of lift force. Either may it be, if now don't go into the complications like how will I get in the air. So that way, there are thrusters and there are other forces using which you are on in the air. And to sustain in the air, you will have lift force, which is acting in the from downward direction, which is again depends on the shape. So we'll not, we'll just leave it at that. Okay. Now, once we stick to this concept, right? If we come to this this image, really focus on this image or even this image. Does it is it closely resembles to the aerofoil shape that we talked about, right? So in order to make wingsuit flight accessible, accommodable, in order to make it fly like dynamic, this wingsuit is designed in such a way that it, when you're in the air, when it's expanded, when you're actually flying, it kind of resembles to this shape. So there might be other like ins and outs or something like this, but it kind of resembles this shape. And when you're flying from it, so basically you will have this thin line. If you speak only about this this portion of it, so you'll see a thin line, and through which basically you are generating enough sustainable lift, where your upper side is also streamlined and you are getting less drag, right? Sticking to our previous point. So this is why recent advancements are made in such a way that you are achieving this shape and accordingly be able to fly a lot longer. Now, coming to its like its kind of execution, like how it works, right? Basically, yeah, okay. Let me just take a few of the questions if you guys have any doubt with this structure. Does anybody have any questions? Okay, so great. So if nobody has any questions, I'll continue. So we are at this stage. We are basically seeing that the shape it generates when you're flying is kind of resembling to the aerofoil shape, and essentially we are getting lesser drag and more lift. But there is a catch. Okay. Now, what the catch is? The first is the aspect ratio. Basically, when we talk about this dynamic, the aspect ratio that I'm talking about, your wingspan, that is the length of this point from this point, is squared, and it is divided by the area of this wing. Okay, and this aspect ratio basically controls the amount of lift you are going to get, the amount of flight you are going to have throughout this dynamics. So in theory, like if you consider it as a ratio, if you increase this length, so this is your wingspan, let's consider, and this is your area. Okay, so this is squared, by the way. Now in theory, if you increase this by keeping the area constant, meaning essentially it's not going to be constant. It is, if you are just stretching your hands. So if you are not in this dynamic, you are just stretching your hands a bit. Okay, and due to which, if you increase your wingspan, you are automatically to increase the amount of lift you are getting, or basically you are reducing the drag that you are going to face. So there are two kinds of drags here. One is the profile drag, which we saw over here. So this arrow mark that I have shown you is going to be your profile drag, and there will be a induced drag. That induced drag will be coming from the resistance that you are going to feel, or it will basically come from the flight suit cross section. Essentially, because this is not an ideal shape, as your aerofoil is ideal shape, this is not an ideal shape, due to which there is going to be induced drag, because there are going to be curves and edges and unwanted shapes forming throughout this flight, like this, something like this. So due to which that restricts, that kind of limits your your flow, it increases your resistance, and that is called as induced drag. Although your profile drag is much more higher than your induced drag, basically your profile drag is around 70%. If you compare 100% drag you're feeling, if you take X amount of drag, that is you're going to be 100% drag, then 70% of the drag will be profile drag, rest of the 30% would be your induced drag in the traditional manner, okay, in the traditional flow. So these are just the numbers that I'm telling you to have it as a reference, and these are actually our real numbers, by the way. So when you have that amount of drag, if you want to, basically you have two kinds of situations in here where you want to reduce both of the drags differently. The profile drag you can reduce by making the flow more streamlined. That means, just a minute, when you have your aerofoil something like this motion will generate the profile drag. So for this motion, essentially what you can do is you can optimize your cross section. You can reduce your overall like apparent cross section, it's called. Apparent cross section in the sense, if I'm visualizing it from this end, if I'm considering this is my front view, then whatever cross section that I'm facing to the wind flow, it will be something like this. Okay, it won't be like a horizontal line. So if it's a horizontal line, then my flow is completely streamlined. But if it's something like this, then it has some flow restriction, right? So let's just consider this shape, whatever its front view will look like, it's going to be looking like a square or something like that. So this is in which you are going to indent your force upon. Now, when you think about this, this is going to be affecting your streamlined drag, profile drag. So this you can reduce by optimizing your wingsuit, like how it behaves in the air, how it muffles up over in the air, and you can control it by introducing different materials. Usually these are made from aircraft canvas, but you can use different materials that that expand, that have more flexibility even with the constant amount of motion. And due to these kinds of adjustments you would be doing in order to reduce the profile drag. Now, coming to the advanced part, coming to the induced drag. The induced drag mainly is induced due to this portion. So as you can see, your wings are divided into two parts. This is your one part, which is your arm side wings, and this is your lower wing part. So this wing part, because of human limitation, you can only stretch it and maintain this position in the air, because when you are in the air, you have to maintain this position. As you can see, this position you have to maintain in order for this flat to be stretched. And you can't stretch it further than human limitations, because there you are feeling a lot amount of force, and in order to sustain this stretch, you have to be comfortable with your stretching. So that's why this is the biggest limit, and due to which the induced drag is mostly introduced. So how to reduce this? So essentially, as I said, when you are making this more aerodynamic, basically you are trying to generate a more amount of lift, or you are basically trying to calibrate your lift with your motion, and that's how you are going to maintain this. So with the natural free fall, we have seen there was a ratio, and with this wingsuit, essentially I'm not sure about the exact details of what the natural free fall has in terms of this triangular equation, but I do know that for wingsuit dynamics, the latest wingsuits, it will give you three times the distance in forward motion as compared to your downward motion. So if you are falling, let's suppose 1 meter, then in this direction, if you are inclined in this way, here is your head, here is your side part. So when you are inclined in this motion, you will attain up to like 3:1 ratio of this. So that means as compared to the free fall, the dead fall that we talk about, you are going to sustain 3 times more in air with this help of wingsuits. So that's what essentially wingsuit dynamics is. So when essentially you are working with this wingsuits, there are a lot more maneuvers you can do. when you are flying, if even if you tilt in, supposedly if you are flying, consider this as the flying man. Okay, so these are his hands, and this is its. So we are basically looking from top. Okay, now we will consider this as our starting point. We are looking from top. This is this man's hands, and this is his head. If we look from the side, if we take it from side like this, something like this, okay, and then if we tilt it in that case, then essentially the incident velocity that you are going to face, or basically incident resistance that you are going to face in this is in this direction. So the action will be in this direction, reaction will be given in this direction, and this is how the dynamic or the free body diagram, you can call it, will work. This is how the balance works. So when you tilt in this direction, what happens is you are accelerating. You are basically accelerating in this direction, and it essentially, because of this angle of attack. So this angle of this angle is called as angle of attack. It's an advanced concept in aerodynamics, but this angle of attack controls how longer you are going to sustain in air. So if you calibrate this angle of attack properly, then you will be able to sustain longer flight. So it's kind of in aircrafts, in airplanes, this angle of attack is managed. This angle of attack is precisely controlled in order to sustain flight. But in case of free fall, in case of wingsuit dynamics, this angle of attack is kind of secondary. It's kind of based on the amount of practice the flying man has. Let's call this man as flying man. This guy has. It essentially depends on that. So it's kind of a general feeling you can talk about. There are a lot of details that goes into play in terms of numerics, in terms of values. But the overall generalized concept is this: if you control your angle of attack, you will be able to easily sustain your flight a lot longer. Now, that was the general idea about the wingsuit design and dynamics. Okay, so when anybody has any questions till this point, you guys can ask. Hello. Am I audible to you all? Some people said my voice was muted.
Audible, sir.
Yes, you're audible, sir.
Okay.
Audible.
Okay. So the last part that I was mentioning, you guys heard it all, right? Okay. So if anybody has any questions till this point, you guys can ask me. Okay. If there are no further questions, let's move ahead. Basically, now we have seen the general concept. Let's just take it from the start. I'll erase some of these things. Now, right from the start, basically we started with the free fall aerodynamics, like how the general free fall works, the drop works. Then we talked about free fall aerodynamics. We talked about wingsuit's general shape, how it looks like, and how its dynamic works. We have deep dived into aerofoil, how it works, its drag, lift, and its coefficients and calculations. Then we saw what are the challenges, what are the basic design aspects through which are considered in order to sustain a longer flight. Now, this concept comes, which is a advanced flow. Okay, without any additional extra support, without any, basically you can attach a jet engine to this thing, a smaller jet engine, in order to boost your propeller, in order to boost your propulsion, in order to boost your flight. and be able to sustain the flight at a more pace. Basically, it will consist of a airplane, kind of a airplane propeller itself. It will be on a smaller size. That could be one way to improve your flight. The other way, the interesting way, is just doing this. Okay, so if I join this using the same material that I use for making of the wingsuit, what it will do is, essentially, it will give me a more area, okay? And due to this more area, I am going to get more larger amount of aspect ratio, because if you consider my wingspan has increased. If I consider this as my additional wing, my wingspan is also increased, and my overall aspect ratio is buffed, due to which I'm getting more amount of streamlined flow. Also, another way it will do is, it will add another element for lift, because this additional area is there. It will add another amount of lift. I will be able to sustain my flight a more longer time without having to do much more, like adding any extra element apart from the extra canvas that I've added. The other way to do this is basically attaching this jet. So basically, what BMW company did was, they have developed this electric propeller, you can call it. It has two sides. It has its two propellers, which are powered by electric power, which are chargeable. And basically, you can attach this to your free fall, or basically your wingsuit, and be able to propel throughout the air. So the general speed at which you are moving through the air with a normal wingsuit is around 100 kilometers per hour. So in an hour, you can reach about 100 kilometers if you sustain the flight through 1 hour. Then, if you attach this propeller, if you use it with the full throttle, you will be able to attain around 300 kilometers per hour of speed. So essentially, if you want to go from one place to another place, which is 300 kilometers apart, you can reach that place in 1 hour, in under an hour. So that's the speeds we are talking about. So this is another dynamic way. So the technology has yet to advance in this domain, like in terms of it's making it affordable, making it executable at a general public level, and also because there is this element. First, we need to get you in the air, where there could be a separate launching system. Then we need to sustain the flight for at least an hour or so to be able to cover that much amount of distance. So for that matter, you will have your propeller, which will keep you in air by providing you extra push, extra thrust, which basically similar concept is being used in aircrafts, airplanes. That thrust we are generating, we are essentially pushing it in the air, and that basically concepts applies over here. And this way, we are basically moving towards an edge where we in future might be able to fly at a better pace. Now, the Spiderman wingsuit that we talked about, the session was about, it has this restriction, as I said, right? The first restriction is we are not having that level of advanced technology in order to generate that kind of material for the wingsuit flight, or the wing that you saw in any of the movies. So that is yet to develop. Second drawback could be this itself, the wingspan ratio, wingspan to the aspect ratio that we are talking about, which we need to essentially increase in order to sustain our flight, in which that adds on extra material. That's why we have this much amount of material, as you can see in this way. If that is optimized in some way or some form, then that could be done. So these are a few of the elements that the suit lacks, or that idea lacks. Basically, in real practical example or application, you can be able to do this. Again, the third thing is the temperature. So when you are flying at this stage, you need thermal resistant materials, which basically this material is. And also for your headgear, that is the most important thing. So if you are talking about a very slim kind of a suit where it cannot have those kind of elements, it has its disadvantages in terms of temperature, in terms of its execution, in terms of the comfort that you want to feel. Also, it has some like the amount of gravity that you are going to feel at that stage, amount of force you have on you, will also affect your blood pressure and stuff. So there are a lot of elements to this aspect which limits this process. But yeah, advancements are yet to be made, and this is how it's going to go. So that was the general idea about the overall program, overall session that we did. So we had learned about free fall concept, aerodynamics of free falling, wingsuit design and dynamics, and its applications. Now, if anybody has any questions at this point, they can ask me.
Hello.
Yes.
Hello, sir. I want to know how we fly in air through this concept.
Okay. So essentially, we have to, again, as I said, we have to be launched from a height. This is a free fall condition where you're not getting a boost like an airplane is getting. If you know about airplanes, like they have this engines installed, and those engines actually help them go in air. But in this case, you have to be already in air using like helicopters or using something, and then you jump off the aeroplane. When
Yes,
you
sir.
jump, yeah, when you jump off the airplane, you will spread your arms, you spread your legs, and through which your wingsuit will have, basically it will get the grip of the air that is filling from, it will get stabilized in the air, where it will have its a sufficient amount of lift force generating and will keep you stable in air. Stable, you will be stable in air, but still you will be descending. You will be going downwards, but still you will be stable in air like this. So you will be going downwards, but something like this. Now, when you are moving downwards, you can tilt. If you can tilt, you can tilt to change direction to basically fly in other direction. You can do all sorts of maneuvers in order to like make your flight more dynamic. If you want to grasp more horizontal distance in terms of kilometers, if you want to grasp, then you need to keep yourself stable, steady. You need to have the general understanding of the amount of depth you have below you. So it has around, like, if you fall from 12,000, 20,000 feet, then in that case you will be able to sustain in the air for let's suppose hours, like 1 hour, more than 1 hour at least. So that itself has its own purpose. So yeah, I hope you get the answer.
Yes, sir. Yes, sir.
Okay. Are there any other questions from any other participants?
Sir,
Yes.
sir, so this wingsuit is only for adventure, right? So it is not for any use in day-to-day life or anything else. It's just for adventure purpose, right?
For now, it is for adventure purposes. In future, we might see its applications in militaries, where if you want to, because currently in militaries, it is kind of deployed in terms of like if something happens to your airborne vehicle. So Air Force usually uses this kind of maneuver tactics. This is another kind of a safety net you could call, in order to, if there is something happens with your jet or um, with the craft that you are moving with, then you can just jump off and glide through using a parachute. You can glide through using wingsuit, and when you are at the optimum height, let's say 4,000 feet, at that stage you can release your parachute and be able to land at a safer stage. So that for these kind of applications, it is more majorly used, and similar way it will be in future. It might get implemented if it's done for commercial usage. Currently, it is just done for adventure and these tactical advantages in the military. So yeah.
Hello, sir.
Yes, Vinayak, tell me.
Sir, that suit during flying, the air will generate sir, stress on person hands and legs. So
Okay.
this will uncomfortable for that person, sir.
Yes, 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 yes. So it will be uncomfortable. So
So is there any solution for that, sir?
the general idea basically is to again, there is no ideal solution for it. Basically, it is adapting to the environment. That's why you have your headgear that lets you breathe in the air, because when you're moving downside, still you will have access to air because there are air gaps provided in that helmet. through which you will be able to breathe normally. Along with the resistance that you are getting, the material that you are having above your hands, it will be coated in, it will be such, it will be very, you can call it as force resistant. So most of the force that you are feeling will be kind of nullified due to the material durability itself. And you will feel less amount of, still you will feel the amount of gravity, the amount of force that you are falling from somewhere, but it won't be as much severe because you are essentially in momentum. So feeling wise, it can work, but yeah, there are blood pressure checks. There are a lot of things that are to be checked before you actually go into this kind of adventures. So yeah, it's not for everybody, as that I could say.
Hello, sir.
Yes, Salman, tell me.
So can we assume it's just only point-to-point transfer of transfer, sir? Like the BMW company is like uh, creating a windsuit which can travel 300 kilometer per
Hmm.
hour.
Hmm.
So I think mm, with
Yes.
implementation of wind turbine or wind blades, the weight will be increasing, and it is a drawback if we increase the weight, then automatically the height of lift or which will be drastically changing, sir.
Yes. Yes. Yes.
So
So
how to? mm,
yeah. So this is the trick. Okay. When you are implementing a propeller, you are powering it with some electric power, electricity. You are powering it up with, and essentially when you rotate that propeller, it will give you a thrust. That thrust force is going to counteract the additional weight that you have imparted upon. So it is in their calculations when they are designing something like this. No doubt there will be this weight factor, but understand we are providing external force, additional force, as opposed to in our other case, in our general wingsuit, we are not providing any additional force. We are just free falling. Just we are using the air to our advantage. We are using that the forces that are coming onto our body as our advantage in gliding throughout the air. But in this case, you will have your up the whole engine to guide you through, to propel you through. Again, there are more resistant material which are lightweight are being used, like aluminum alloys to build the structure, even carbon fiber to build the structure. So there are a lot of elements. So there are a lot of design challenges, or basically make it. That's why it is more expensive, more on the expensive side. And essentially, the flight dynamic, right? When you are falling, free falling, you are still going at 100 kilometers an hour. The only additional point in the BMW upgrade is going to be it will going to take you from 100 kilometers, moving at 100 kilometers per hour, to 300 kilometers per hour. Additional element, you can even propel in upward direction. So basically, if there is this, if anybody is seeing my screen, I'll just pin my screen. So if you have this kind of the propeller jet, and if you even want to soar up in the sky, then you just want to activate the propeller, and then you can just take a quick lift off from that position in mid air. So this is how it is. It could be tactical advantages. It could you can again, if you are free falling, you can use the propeller to reach a certain amount of height and again free fall. So this way you are generating this kind of pattern, and that way you are basically staying longer in air. So if this the bottom blue line you are seeing, this is our ground. If you are at this stage and this is your sky, then you are basically going to go something like this, and essentially elongating your flight, because still you are in air. This distance is going to be there always until you run out of fuel for the propulsion. So these are the ways to improve your flight dynamics.
And sir, even what about the glide ratio, sir? Glide ratios is fixed, right, sir? 3:1. If we move around, let's say 3 meters forward, we will pull down 1 meter downward. So I think it won't be. It will be a major drawback, sir, for wingsuit.
Meaning, I'm not understanding.
Which means we need to consider a glide ratio concept also, sir.
Yes,
Like
yes. So I purposefully didn't go into the depths of it because it kind of gets overbounded from our discussion. So I just covered the general aspect of the concept. There are other aspects, as I said, there are other forces which will be taken into account. Like as you said, glide ratio is going to be one of the part that is going to heavily influence this. So this is just one concept that I showed you, that how we could do this. But if this is still it is possible or not depends on the calculations. It depends on the actual execution of it. The general when the flight man, the wingsuit man who have developed this BMW engine or BMW propeller has actually that flow, right? Has actually that kind of um, dynamic installed. So he has considered all these conditions, and accordingly they have tested it also. So there is a video on YouTube, a short clip around 4 minutes or so. You can actually check that out as well. Okay, now as we are nearing to our time limit, I hope all the doubts of all the students have been answered. I'll just share the certification form link in the chat. Basically, this certification form link will, a minute. Yeah. So this is your certification form link. So you can fill out this form and get a one-on-one free counseling from our experts. So this is one of the concepts, right? What talked about aerodynamics. If you have other concepts in mind, like what about its design, what about its analysis, what about different domains altogether in terms of automotive, what is going on, what sort of if you are interested in different domains, like even if you far-fetched it, data science, machine learning, artificial intelligence, if you are even interested in different domains, based on your interest, you will be completely thoroughly taken through a complete session. Our experts will understand what domain you want to work in, accordingly give you a suitable program through which you can actually accomplish these things. So along with the certification, you will also be able to avail the free course that we have in that particular domain itself. We will provide you with a free course of within that particular domain, like if it's related to computational fluid dynamics, if it's related to aerodynamics, if it's related to engineering design, etc. You will get a free course. You will have a project to do through that free course, and after completion of that free course, you will be getting a certificate based on that free course when you complete that free course. So that way you will be able to even improve your understanding furthermore in the domain which you are interested in. So do fill out this form, and all the best to you all. All in all, in conclusion, I again would like to thank Kshatriya College to have given us this opportunity to conduct this boot camp. So really thank you, sir. Mr. Veda Prakash. In conclusion of our session, if Mr. Veda Prakash is here, if you want to say something, if you want to speak a few words in concluding this session, then please go ahead. Hello. Yeah. So if Mr. Veda Prakash is not here, then I'd like to conclude the session. Before that, I just yeah.
Sir, up to that, I was not received any single certificate from this ETG, sir.
Okay.
So what kind of problem there is, sir?
So basically, we have these webinars or boot camps, you could call it, on a weekly basis, right? Twice a week there are boot camps, and there are multiple people that comes in, and due to which the certificates are generated and circulation is kind of we are trying to figure out. I'll check with my team and get back to you. In the meantime, you can actually check your email ID, check your spam folder, check
Sir,
your
I
all the
checked
folders.
already, sir. But up
Yeah.
to that, I was not
Then-
received any single schedule, sir.
Okay, then please put your email ID in the chat. One of our operations people will take care of it. Okay. Mohammed Salman here has, and please put valid email ID. Okay. Otherwise, that would also be creating a problem. So, Mohammed Salman says flying squirrel anatomy means, please cover this. So, it is same concept, okay? Instead of a wingsuit, the flying squirrel has its own skin, and it is kind of a natural wingsuit, you can call it natural wingsuit, which helps squirrel to glide through. But again, there are limitations. When a flying squirrel jumps off, it gives her a limited amount of flight. That's why she uses this flight from jumping from one tree to another, escaping from wild animals. So this is the basic idea of that flying squirrel is. So then that's actually covers from my end of the thing. And I again thank Mr. Veda Prakash and the Kshatriya College to have came on board with this bootcamp with us. So thank you very much all. Take
Sir,
care.
I sent my email ID, sir.
Yes. Yes, sir. Vasudev, do you want to say anything?
No, sir. Okay, I thank you. Want to tell you.
Okay.
Thank
Thank
you.
you very much, everyone. Yeah.
Thank you.
Yeah. You guys have listened to me with a patience. Keep learning, keep exploring, keep sharing what you know. Take care, everyone. Fill out the form so that you can avail the free counseling and free course. And have a nice day. Mohammed, if you're watching on YouTube now, we are just sorting that out. We will address this comment outs you're saying, right? So we'll address this. Thank you very much, everyone. Take care. I'll take your leave.
Thank you, sir.
Thank you, sir.